Hey guys, welcome back to Nerdy Crew. I hope you all are doing great. So today we'll be doing the optimal solution of sort colors problem. But before watching this video, make sure that you watch the part 1 because there I've explained the problem statement. So now let's start with it. So the most optimal way to solve this problem would be using a Dutch national flag algorithm. Basically, this algorithm allows you to sort an array of 3 distinct elements in a linear time complexity and with constant space. Alright, so now let's understand this algorithm with the help of an example. So I'll take the array consisting of these elements. Fine. Now remember that there are 3 pointers which we use in this algo. The first one is low, which points to the 0th index. The second one is mid, which also points to the 0th index. And the third one is high, which points to the last element. Fine. Now, the second thing which you need to remember is that this array will be divided into some parts. What are those parts? See, the first part will be 0 to low minus 1. Now, this part will contain all the zeros. The next part will be low till mid minus 1. This part will contain all the ones. Then we'll have high plus 1 till n minus 1, which will contain all the 2's. So if you see carefully, you will see that there is a gap here. We don't have the elements from mid till high. So the elements from mid to high are missing. So mid to high. Now you must be thinking that this part is consisting of zeros, this part is consisting of ones, this part is consisting of 2's, but what about this part? So basically, this is the part where our unsorted array or sub-array exists. This is the unsorted part of our array. Okay, so right now you might not be able to relate this thing with this example, but you will. Let's see how. If I try to sort this array partially, and then you will see that you will start observing this pattern. So after partially sorting it, I'll get this as the answer: 0, 1, 1, 0, 2, 2. Also, the pointers would have moved a few places, so low will come here, mid will point to this index, and high will point to this index. Alright, now you will start observing this pattern. So here it is stated that from the index 0 till low minus 1 we have all zeros. So see, this is 0 till low minus 1 we have all zeros. Now from low till mid minus 1 we need to have 1. So see, this is low till mid minus 1. So this index we need all ones, we have got a 1. Now from the mid to high we have the unsorted subarray. So this is our unsorted part. Now the last is high plus 1 till n minus 1. It contains 2's. So this is high plus 1 till n minus 1. It is containing all the 2's, right? So you observe a pattern. Now since you have understood this thing, let's take our original example back and we'll try to sort it. So this was our example. Now this is where mid lies, low will lie here and high will come here. Now tell me this one basic thing. If I have sorted my left with all the zeros and if I have sorted my right with all the 2's, isn't it obvious that my middle will be automatically sorted? Now let's start iterating in this array. Now mid is pointing to 2. I know that if it is a 2, it should actually be in the extreme right. So I'll swap it with the element at high with the element at mid. These two elements will be swapped. So if you get mid pointing to 2, you should swap the element at mid with the element at high. Let's swap them. So it will be 2, 0, 1, 1, 0, 1, 2. Which is the same array. You've not made any change right now. But now you are sure that your this range is sorted. If your this range is sorted, you can decrement high. So high should be decremented. Okay, so high is decremented, but what about mid? Should I increment mid or not? I can't, because you see that after swapping I get the same element, which is 2. And if I increment mid, it could pose a problem because I'll end up missing this point. Fine. So I should not increment my mid because right now I'm not sure that this part is sorted. So mid will stay here, low will point to this index only. Now you get a 2 again. So again, this element should be swapped with the element at high. So let's swap them and you will get this as your answer. And high will come to this point, mid will come here and low will come here. Fine. Now our mid is pointing to 1. Mid is pointing to 1. What to do when mid points to 1? Should I increment my low, or should I increment my mid, or should I increment both of them? The answer is I should only increment mid. Because the only time when you increment low is when you are sure that this range contains all the zeros. Fine. So you should just increment mid. We are incrementing mid. The reason is that we are somehow sure that this part is sorted. So let's just increment it. Now what will happen? We'll get this as the answer. Now mid is pointing to 0. What to do in the case of 0? If your mid is pointing to 0, you know that this element 0 should actually be in the extreme left. Therefore, it should be swapped with the element at low. Fine, because your low should actually be having 0. So let's swap them. And you get this as your answer. Now, alright. So if you have a 0, you should simply swap the element at low with the element at mid. Now I've swapped them. I should also increment low because now I know that this range contains all the zeros. What about mid? Should I increment mid or not? Should it be incremented or not? The answer is yes, I should increment it because we increment mid when we are sure that some part is sorted. Fine. I should increment mid. Now also I should increment low also. Since we are sure that this part is sorted. Fine. So mid will come here. Now again mid is pointing to 1. Simply increment mid. Do nothing, just increment. And we'll get this as the same answer. Mid will point here and high will point here. See, so far you can see that it is getting sorted. This was the same thing which I explained in the example above. Okay, now I have again 1. Simply increment it. We won't do anything much because we are sure that till this part it is sorted. So 1, 1, 1, 0. Mid will come here, high will come here, 2, 2. Sorted. Again I have a 0. Therefore, this mid should be swapped with the element at low. Let's swap them. So 0, 1, 0, 1, 1, 1, 2, 2. Fine. Now low will point to this index because this range contains all the zeros. Also, now I'm pretty sure that this range is all sorted. So let's increment mid also. So mid will point here and high will be at this index only. Now tell me one thing. Is there a point of incrementing mid again? Is there a point of checking that this part is sorted or not? There is no point, right? Because high has already made sure that this part is sorted. So now let's just stop. So remember this condition that if your mid exceeds high, you should stop. Your mid should always be less than or equal to high. Fine? I hope you have understood this thing. Okay? So I hope that you have understood this thing. Now let's code it. Okay, so first we'll have 3 pointers, which is low pointing to 0, mid also pointing to 0, and int high, which will be pointing to nums.length minus 1. That is the last index. Then we'll have a loop which will iterate till mid is less than equal to high. Now we'll have 3 conditions. The first condition is if nums of mid is equal to 0. The second condition will be else if nums of mid is equal to 1, and the last condition will be else when mid is equal to 2. Fine. Now if nums of mid is equal to 0, we have to swap the two numbers. So for that I'll pass in the array, then I'll pass the mid, and then I'll pass the low. Fine. But right now we don't have any swap function. Let's create this function first. So public static, and we won't be returning anything, so void swap. First we'll have an array, so int nums, then we'll have int, let's say int first, then we'll have int second. So these are the numbers we'll have. So you should know how basic swapping works. So for that I'll say int temp is equal to nums of first, right? Then I'll say that nums of first is equal to nums of second, right? And finally I'll say that nums of second is equal to temp. This is how the basic swapping works. Now once I have swapped, the next thing would be incrementing the low pointer and also incrementing mid. Now if we have nums of mid as 1, we'll simply increment mid, if you remember what I taught. Now if our nums of mid is equal to 2, in that case I have to first swap the element. So again we'll pass in the array, then I'll pass in the mid, and then I'll pass high. Fine. And after this is done, I have to decrement the value of high. So this is how it should work. Now we don't have to return anything in this case also. So let's try to run it. Let's see that are we having any errors. Okay, it's fine. So also let's submit it. Yeah, it is submitted. And when it comes to the space and time complexity, we are not using any extra space. So the space complexity is constant, and the time complexity is we are only iterating once throughout this array. Therefore, it is going to be big O of n, that is the linear time complexity. So I hope you have understood this lecture. If you like the video, please make sure that you like, share and subscribe. Thanks for watching.